So we talked a lot about how we may understand the beginning of the universe. We started with a cosmic micro background that gets us back to the stage when the universe was 380,000 years old. Then we also looked at the original chemical elements and found that helium had been formed when the universe was only 3 minutes old. Then dark matter got us further back when the time of the universe was like a 10 billionth of a second. And Higgs boson frozen into the universe when it was only like a trillionth of a second. Antimatter, if this idea with the neutrinos would work out, gets us back to a very beginning, right after the inflation. We don't know exactly what the time scale is. And the inflation itself, when inflation planet sees for the structure we see today that led to the formation of stars and galaxies, that was planted right at inflation. And that's as far as we can get back to the beginning of the universe right now. Now we switch our gears to think about the future of the universe. And that's one of the really basic questions. When you think about the universe, okay, will it have an end? Or does it go on forever? What is the fate of the universe? It's a very natural question. Of course, we are very interested in knowing the answer to. Now, we talked about how the universe expands. And as I told you, the expansion of the universe, as we were told by Einstein, is the same thing as holding a ball and give is the thrust upwards. So the way the ball has a thrust at the beginning corresponds to the Big Bang. How the ball keeps going up into the sky tells you how the universe expands. And given this analogy, it's very easy to tell that the ball should become more and more slowly as it goes up, because the gravity only pulls, it never pushes. So we always felt that the universe should decelerate, should slow down instead of accelerate or speed up. This is what the prediction of Einstein's theory of relativity was. And that's what we believed for 7 decades, actually. So believing this is the case, then the universe could have had only 3 possible fates. I talked about this before, but let me repeat this here. So if there is a sufficient gravitational pull, so if I hold a ball, thrust it upwards, then it keeps going up for a while, but eventually stops, and keeps coming, and then comes back down, and boom, falls on the ground. And that is one possible fate of the universe. It goes up for a while, slows down, stops, comes back down, and boom. And that's the big crunch. We talked about that. But if you actually put initial thrust with a rocket, then the ball may escape the gravity from the Earth and then may keep going forever. That is this red curve. So in this case, the universe would not have an end, just keeps expanding forever as sort of a free motion. Exactly in the middle between 2 cases, this is exactly the right kind of initial thrust that would barely get you escape the gravity of the Earth and then sort of more or less stop towards the end. But again, the universe would not have an end in this case. So what we would like to do then is simple. We would like to measure on which curve we are on by looking far away, which means you look far back in the past. By looking at how the universe expands nearby, that measures how the universe is expanding more recently. If you measure how the universe was expanding far away, you're measuring how the universe is expanding far back in time. By connecting the dots, you would like to tell on which curve you are on. And once you know which curve you're on, you can forecast the future and tell the fate of the universe. And that's what we would love to do. And it turns out that these 3 cases correspond to 3 different shapes of the universe. And if the universe is flat, we're supposed to be on this curve. If the universe is curved in this strange way, we're supposed to be on that curve. On the other hand, if the universe is sort of like a sphere, then we're supposed to be on this curve. And in this case, not only the time is limited that we would head to the big crunch, space is limited too. So in this case, if you keep going that way on a spaceship, eventually you find yourself coming back from the other way, just like what the Magellan did on his journey around the globe. If you keep going that way, you can come back from the other direction. So it will be very interesting to know which kind of shape we have for the universe, which is also related to the fact that which kind of fate we have in the future for the universe too. So that's why this question has attracted a lot of attention, and people wanted to measure which curve we are on by measuring the expansion speed far away and nearby and compare them. And that's the kind of measurement indeed people have done. One thing which is clear, though, that if the universe is slowing down, is the future observers would have a really good time, because more and more objects would come into our sight. So the future observations will be even more fun than the fun we are having today. But everything changed in 1998. It was discovered that the universe is actually accelerating, and we would like to talk about it. So what is this dark energy thing?